Welcome to Breaks Optional. This is our second season, first episode. I am Jonathan Pearson.
I'm Elroy Pearson. It is
Okay.
September 6th, 2025.
And I'm Damon Pearson.
All right, for those of you who are new to the show, I guess our format is rather simple. This is just an opportunity for us to get together and we talk about things that we found in the news or online that we find interesting. They tend to center around our own geeky interests. Everything from me for I love VR stuff, and so I tend to focus a lot on that, or retro gaming, things of that nature tend to be my focus.
I tend to like things to do with cars and engines, space, and I professionally make holograms, and so I have an interest in optics and holography as well.
I tend to like space exploration, space news, astronomy, and then more nuts and bolt kind of technical stuff, like Elroy said, cars, motorcycles, rockets, airplanes.
All
This
right.
is good.
Excellent. All right, we don't have much of a right now. We've got nothing formally established how we're going to handle this order here. So I guess if there anybody who's dying to talk about something that they've discovered recently that we want to talk about here.
I'm not dying, but okay. I'm going to be departing a little bit from my normal hyper focus. You know, like I said, usually I'm focused on space exploration, astronomy, quantum mechanics, physics. I love that stuff. It's fascinating.
Right?
So I'm gonna go back a few months, almost a year. My boys, I've got 3 sons, and they love Minecraft. And my oldest son, he's an adult now, but Blake, when he was younger, he got into Minecraft, and all the time I probably didn't show as much interest as I should have for something that he was passionate about. I just couldn't
Chicken
see how it
jockey.
was. Yeah. Oh goodness! Don't get me started on that show. Anyway, so last December, I took off a week and a half of work. From about the 20th of December to like the 2nd of January, and that whole time, my boys twisted my arm and they're like, "You have to play Minecraft with us." And so I acquiesced, and we spent almost 2 weeks playing Minecraft day and night, and we had a ton of fun. And anyway, at first I thought, okay, this is just a simplistic, dumb game. You get blocks of stuff and then you build it. And to me, that just seemed like, I don't see what the big deal about the game is. But as I learned more about it, I learned that you're not limited to a storyline. You're not kept on rails like a lot of video games.
Sandbox.
You can go and you can do whatever you want. You can build whatever you want, and you can use the environment, around you to build whatever you want. And what's cool about it, to me, what really struck me is, okay, so for work, I'm a process engineer, and that means that I have to okay, I love processes. Like chemical processes and manufacturing processes, they're fascinating to me. And because they're very complex, and each little piece of it affects upstream and downstream. And getting processes to work and to flow good, to flow correctly.
Not good.
It takes a lot of thought, a lot of brain power, a lot of knowledge. And a lot of that involves knowing the properties of the materials that you're using. And what's so fun for me about my job is that uh, you can be as creative as you want, and that's fun. Like that's fun for me. Like you're given hard problems, and then you use your own creativity to get to like work your way out of the problem, and I love that. And I realized a few days in, playing Minecraft with my boys, I'm like, oh, my boys are doing like what I do for work. They're doing it for fun, and that kind of blew my mind. And so I started talking with my boys about it. I'm like, you guys realize that you guys are learning engineering processes. Like you're learning how to make these complex machines and systems. Like, for instance, in the game, you can trade with villagers. They're just NPCs, and um, through your interactions, it changes the way that um, the villagers interact in return. Like you change the market by being in the market. I'm like, oh my goodness, this is amazing. Like I didn't realize these details about it. And Blake, he built a he built a building, and he captured villagers, and he put them in their own stalls in the building, and he gave them all the things that the villagers need in order to be happy and productive. They need a workstation, they need a bed, they need they need to not be under stress from the bad guys coming around. And so he built this building and made it very difficult for the bad guys to get in, and made it a fortress. And he made it so that he had this like self-contained marketplace. And so those are just I guess some simple examples. But then come to find out, people have built fully functioning computers in game. That blows my mind. So you're making a simulation of a computer that's running on your computer, like fully functioning. They make logic circuits.
Right.
People have made they've played Doom. They've made a simple not a simple. They've made a computer that plays Doom on a screen in Minecraft. Like
Oh, wow.
it's amazing to me.
So my boys, I've got two sons, and when they were teenagers, they had gotten into Minecraft and discovered redstone, which is kind of the electricity block, I guess. And you can do logic with it. And they were making logic gates and logic circuits like these computers. It wasn't anything like Doom, but they were doing that kind of stuff. Yeah.
I've seen stuff like that online. I've like my kids have never done anything quite that elaborate, but they love it. They build stuff all the time in there.
Yeah. Well, I think I fell into the mistake of just thinking, oh, this is just a silly game about blocks. And I think that's incorrect. That's not the right way to think about it. Because, like I said, my boys, I can see them working through problems and solving the problems with the knowledge that they have and the materials that they're able to get. And to see them work really hard, like if they realize, hey, I could solve this problem if I had these resources and traded with these people, and like to see them put the plan, it like that's difficult for a 10-year-old to do. And I'm seeing that thought process developing in my boys, and it's so fun to see that. And I think that it's way more valuable than what I ever gave it. Like I guess whatever I assigned to it in the past. Like this. Like for me, I did go to school for mechanical engineering. I never did get my degree, just so you know. But that laid like a really good foundation for me. But what really like got my brain into the like lifted the heavy weights for me was being in alternate fuels and making biodiesel and veggie oil systems for diesel engines. for 10 years.
Right.
And kind of the same thing, like solving problems and just being as creative as I wanted to be, and
Right.
to solve the problems. Just, like thinking like, what are the properties of these materials? Like what could be causing this problem? How can I solve the problem? And so for me, it was the biodiesel and the alternate fuels thing. But I'm seeing, like I said, I'm seeing the same thought process being born in my boys, and I'm so proud.
Yeah.
Have you
And
ever?
Well, I
and
think when we were kids, that maybe somewhat equivalent to that was our Lego sets that we
yeah,
had, because we had Lego sets. Our parents were awesome enough to buy some Technic sets that had like gears and wheels. We never had motors, but um, we we weren't quite well enough off to get Transformers, and Transformers were all the rage at that time. And so we built our own Transformers out of Legos. Uh, and
remember.
it was an open sandbox, if you will, and
Yeah,
the limit was just your own creativity, and to a certain extent the materials that you had to work with, but it was
yeah,
much less of a limit than one would think.
I was never quite creative enough to create Transformers or things of that nature. I always ended up just doing stuff like taking a Lego man and making them have really, really tall legs, like Lord Business in the Lego movie.
Yeah. Well,
yeah.
I
I
think
remember.
that, there's some interesting psychology there, because when Minecraft came out, it completely subverted the direction that video game companies were going. And it was made by a single guy at first. And, it didn't look to have amazing computer graphics, but it used basic graphics, but then looked to make a creative environment. And that creative environment just really connected with kids on a level, and it's amazing the longevity that game has had, you know.
Yeah,
Well, and there's a focus on, rather than making it visually stunning, that focus on developing systems as, I guess, yeah, that's what you would call it in what they call it in the video game industry. When you have systems that run where basically you have a whole bunch of elementary elements, obviously, and then simple elements, that's what I'm trying to say, but then they all interact in these unique ways, and you have to know, how does this kind of block interact with this kind of thing? How does this tool interact with this? How does fire interact with these things? And when you get all these elements working together, then you can create those fascinating things like I don't know, chicken factories, or iron factories that shoot out iron ingots, or whatever it may be. Just
yeah.
Yeah.
crazy stuff.
That's
And it's so, like, okay, you start out with very simple building blocks for the game, and it can get complex real fast by, like what you said, how things interact with each other. It's like almost like chemistry, like how it keep. This is my son,
Hey, Bridger.
Bridger, my middle son. He says hi.
Hi, Bridger.
But it's like chemistry is very complex. By the way, you chemists, chemical engineers, holy cow, my hat's off my hat is off to you guys, because that is a hard field. I love it, but that's what Minecraft gets like. Like, there's so many interactions that you think how something is going to interact, and there's exceptions to the rules, and it's fun. It's fun to find those, and it's fun to
Yeah.
harness those.
Well, it's interesting. I'm playing my own Minecraft game right now, in real world. um, I've taken on a project. You guys know about this, but our viewers do not yet know about this. I've taken on a project building a hologram printer that makes simple holograms, diffraction gratings. I can't say who I'm making it for, but what I can say is it's going to make pixel rainbow clouds. It's for an artist, and this is along the lines of something I've wanted to do for a long, long time, is to build hologram printers and eventually build holographic video displays based on concepts that I have. And it's basically figuring out, what does this thing need to do, and then what's available to me, and how do I make it happen. And just that creativity around a really challenging project or problem is just so much fun. I mean, sometimes it gets sometimes you get a little burned out if you've been working on it for a long time. You take a little break from it, and then you come back and you're ready to attack the problem again. At least for me, that's how it goes.
That I think that we not just us three, but all of us maybe need to be a little bit more careful in dismissing, just games, because I think that they can be very useful. They can be maybe not so helpful, but I think that some of them can be very, very useful to society in general. Like people developing that sort of a thought process is essential for a complex modern society. And so I think Minecraft actually does a good job of that. You can
Yeah,
you
that's
can
cool.
take that same kind of thought process and move it into computer engineering, move it into mechanical engineering. Like you can move it into all kinds of fields, just like you're just playing with different building blocks.
Well,
Yeah.
you talk about that. A lot of software developers. That's what I do for work. I'm a software developer. You guys know that. Our viewers maybe not, but a lot
Oh,
of
come on, mom
software.
knows what you do.
Yeah, that's true. Thanks, Mom. Um, a lot of us kind of got started from like hacking in video games early on, and I don't know if that's common now with newer generations who are getting into it. But I know for me, my story was when I was a kid working with QBasic, making stuff like a stickman that would walk across the screen. I think Damon, you helped me make that, or was it Elroy? I don't remember.
Remember,
But yeah, it was.
remember, we made a stick man, and then we kept modifying it until he had a machine gun, and he was walking across the screen like John Rambo. I remember,
Why does that not surprise me?
right?
And then as I got to be a teenager, I started playing a game that had some heavy modding tools, and learning how to write code for that was an interesting challenge. And I'll never forget.
It was Peasant's Quest.
No, it wasn't Peasant's Quest.
Oh, okay.
But there was. I wanted to make it so that you would have characters who followed you from screen to screen to screen to screen, which wasn't a built-in tool. And I can remember going through that process and figuring that out. But that allowed me, when I did finally get to the point where I decided to make it a career, that gave me the tools to be ready to start analyzing code in that way. I imagine it would be a lot easier now to go back and write those things that I did when I was a kid. But I guess that's what I think of when you talk about Minecraft and teaching engineering skills. Makes me think of just playing games on the computer and trying to make my own, because it looked so approachable at that QBasic level.
Yeah, I think the principles are the same. I think that somebody can develop useful real life skills just by playing. So play is important, I guess. That's the moral of my story. Play is important.
Yeah, yeah. Well, and this isn't new. This is down through the ages. Kids have played, and you know, a lot of times those things that they are enraptured by when they're young develop into hobbies or professions that they go to later, like building a tree fort, like what back or playing with like back in the 50s, when our dad was a young man, he and his brothers would play with cars, and modifying them. Cars were a lot simpler back then, but that's something that stuck with them, and they would, take a couple of wrecked semi trucks and chop them in half, and then weld them back together and get one working semi truck, that kind of thing. But it's just that creativity that continues to spawn and and grow, and like there's a lot of people that just really enjoy I would say everybody loves creativity, but I just don't know. Like, I think most people like to be creative on some level.
That is an interesting point that you make. I just always assume that everybody likes to be creative, but I don't have any data behind that. I fall into the trap often where I assume that everybody thinks the way that I do, and that is a horrible assumption.
I can state emphatically that not everybody thinks the way you think, Damon.
Well, after almost 5 decades on this planet, I am slowly coming to realize that. Taken me a while.
So I probably spend too much time watching the YouTube, and so has been coming up on my feed the last while is World War II aircraft, and I just find it. I mean, World War II was an awful time. Like it was awful, but some of the innovations that happened and just the pace of invention was just astonishing during that time. And the fighter aircraft, well, aircraft in general, there's so many different things that were tried, and there's some just really fascinating models that came out of it. So there's a couple of airplane models that are really fascinating, at least to me right now. And those are. Ooh, what is that? You got a book on World War II aircraft?
Aircraft in general,
wow.
but yeah,
Okay.
I'm excited for this topic.
Yeah. So the two aircraft that I want to talk about a little bit tonight is the P-51 Mustang and the P-38 Lightning.
Yeah.
And each of those aircraft had some just really unique adaptations around cooling the air going into the engine. In World War II, there was a huge challenge. World War I had introduced airplanes as part of the war, but that it took the form of these aces flying around in biplanes mostly. And when they would get close enough to the other pilot, they would pull out a pistol and shoot at the shoot at the other pilot. And so it was kind of a gentleman's sport, if you will, to fly your biplane and battle it out with the other pilot. World War II aircraft became strategically important, flying across the English Channel, the Germans attacking London, and then the British attacking back over the Channel and eventually into Germany with bombing runs. And so you were starting to see airplanes go up to heights like 15,000 feet, where the air pressure, the available oxygen was different than it was at ground level. So aerodynamics started to behave differently, and engines could get starved for oxygen, and so they couldn't maintain horsepower to keep the airplane flying. And if you had a slow airplane, then you became a sitting duck, because if the other side's airplane was faster, then you were not going to win the dogfight. And so, I'm gonna share my screen here, and I'm gonna go first to the P-38 Lightning, just to show. I think Damon knows what this looks like, but I'm guessing that Jonathan maybe doesn't know
Yeah, probably not.
what this looks like. All right. So this is a page showing different angles of the P-38 Lightning, and this is an interesting design, designed by one of the most famous aircraft
Kelly
designers of
Johnson.
all time, Kelly Johnson.
Yeah.
Kelly Johnson ended up running the Lockheed Skunk Works, and out of the Skunk Works came some really amazing aircraft. The SR-71 Blackbird is one of them. I don't know if you know that one, Jonathan.
I
sleek-
just assume I don't know anything. You know.
What?
Okay. So here we go. SR-71 Blackbird. This was a spy plane during the Cold War. This thing was
Oh my goodness. It's one of the coolest airplanes ever. I believe so, yes.
Yeah.
Oh, these
You got
things
some
are so
factoids
cool.
for us on this?
Yeah, I can start just rattling them off. Okay, so these did not use normal jet fuel. These things used different jet fuel that was much harder to ignite. So they had to have a different chemical that like, so if they had an unstart, like an engine that the combustion died in, to start it back up on a normal engine, you could just throw your jet fuel in and have some igniters, ignite it, and you'll be back up and running again. On these things, you had to have this other chemical, and I forget what it's called. It was some nasty stuff that they would inject in the engine, and they only had like 8 shots of it for a flight. So if you hadn't had engine die more than 8 times, then your engine was just dead for that flight.
Oh.
Also, these things are supersonic, so
yeah. Like what? Almost Mach 3? Is that what it was?
Oh, geez.
How fast was
Yes.
the SR-71 Black? Okay. How fast? Oh, look at that. Google knows my brain. 2,200 miles an hour. Mach 3.2.
Yeah, there we go. What's really cool. So if you see, can you pull up? Hey Jamie, can you pull up the picture? Just any of those pictures so that we can see a close up of the air inlets. This is one of the coolest bits of engineering on these things. So okay, right there. Yeah, that one. Okay, you see those spikes in the air inlet? Those spikes are hydraulically controlled, and they move in and out, and they focus the shock wave, because a jet engine can. Here's my problem. I'm really excited about this. I'm really excited, but I don't know how much detail other people will care about. And I find this problem often is where I'll be really excited about something, and I'll just want to like info dump on somebody and share with them. I'm like, hey, this is exciting. Here's some excitement. And a lot of times they're not as excited, and that makes me sad. But this bit of engineering is super fascinating. As you transition from subsonic flight to supersonic flight, everything changes. Like the way that the air acts is different. So, you can either design your jet engine to work really well subsonic, or you can design it to work really well supersonic. And trying to make them work in both regimes is really difficult. And what they did here is they made it so that spike would move in and out, so that like under normal flight, the air just comes in and just flows over it, goes into the engine, and then it gets heated up, and then it gets accelerated out the back. And then whatever, Newton's third law pushes your airplane forward. That's right. Newton is out there pushing your airplane. But once you hit supersonic, then all of a sudden you've got to deal with air that's moving supersonic. And if you try to shove air that's moving at supersonic speeds through your jet engine, you're going to have a bad day. You're going to run into shock waves happening in all sorts of uncontrollable places. And it's going to start like blowing bits off of your engine, and you're not going to have a very good flight if you do that. So what they do is these kinds of engines aren't just a jet engine, a turbojet engine. They are a scramjet. So a scram engine, it doesn't use a jet engine. It just uses the speed and the shock wave to compress the air, and then you add fuel to the compressed air, and it ignites and goes out the nozzle out the back. A jet engine uses spinning fan blades, more or less, a whole lot of them, to compress and then accelerate the air out the back. Right? These use a combination of both. So the spike moves forward and backwards, and it can focus the shock wave exactly where they want it, and that shock wave compresses the air. And as long as they keep that shock wave exactly where they want it, like right inside the nozzle, then they can keep their engine living, and they can they can fly more efficiently at supersonic speeds, because the engine isn't doing all the work to compress the air. The shock wave is.
Oh, interesting.
Fascinating.
Yeah.
So that means these things were designed in the 60s. They didn't have microprocessors. This was a hydraulic computer controlling those things.
I
Oh,
believe they started to be designed in the 50s, I believe.
Oh my goodness. A hydraulic computer, though. Yeah.
Let's see, what? Yeah, they were, the Skunk Works program was amazing. Kelly, okay, you're right. In the 60s, it says, but the Kelly Johnson was just an amazing horse. Well, it was revealed in 1964, but they were working on that for a few years before that. Amazing. So another interesting thing about this, one more thing about this, and then we'll go back a couple decades to World War II era planes. When this plane is on the ground, to get it started, there's a cart that has two V8 engines on it that you run up in front of this and hook, I think it's via a shaft, to the engine to get it spinning, and that's how you get the engine. It can't start itself. You had to wheel.
Can I make a real quick
Yes.
technical correction? It's
Yes,
maybe
please.
nitpicky, but it uses air to start the engines. So
Was that what it was? Okay.
Yeah. The V8s spin up compressors that move air, and the air, like a big hose, hooks up to the engine.
Oh, interesting.
Okay.
The jet engine.
I did not know that.
And
And
can I interject an interesting tidbit? So
you're going to tell the thing that I
cards.
was going to tell.
Oh, go for it.
No,
The start card. I love this.
I think it is different. Go ahead. You tell it. That's not what I was going to say.
Oh, okay, so those carts that Elroy was talking about have two V8 engines in it, and as designed, they used Buick big blocks, which nowadays it's unheard of. A Buick big block, what the crap is that? There aren't any. Well, the reason why there aren't any is because the SR-71s used them all up. They literally, the program only had several dozen of these airplanes, but it was so hard on these engines running this, starting up these jet engines, that they wore out so many of them that they would go around to the junkyards, and they bought up every one of these Buick big blocks that they could find, which ended up making, like, they literally dried up the market.
Wow.
Oh, that's crazy.
Yeah.
I did not know that. Okay, so my other tidbit on this was that when you fly at 2,200 miles per hour, the speed of air over the skin of your airplane, it's extremely hot. Hot enough that it changes the length of all of your panels. When the SR-71 sat on the runway tarmac, it leaked fuel. It wasn't sealed up. It wasn't until it got flying at speed and all of those panels started heating up that they would grow together and seal the tanks, and it would stop leaking fuel. And then it could refuel in the air and then off to its destination.
Oh, I love it.
Oh, that's
All right,
nuts.
so
Can I tell
Anyway.
another real quick?
okay,
Okay, so these things are made out of titanium.
yes,
The titanium at that time was incredibly rare, or at least incredible. It wasn't a readily available material like it is nowadays. When Lockheed started this project, they're like, we're going to need a lot of titanium, and there's not enough titanium ore that we know about in the United States or in our sphere of influence. The only place that has enough titanium ore is the Soviet Union. So the CIA set up a bunch of puppet companies in third party countries, a whole bunch of them, and they made this huge titanium market. All these different competing companies all buying titanium from the Soviet Union, which actually were all the same company going back to Lockheed to be used on an airplane to spy on the Soviet Union. So,
uh-huh. All right, we're gonna rewind a couple decades
oh, good.
back to the P-38 Lightning. I believe
Amazing.
that this was designed. This was the brainchild of Johnson. What's his first name again?
Kelly Johnson.
Kelly Johnson, when he was like 24, 25 years old.
Yeah.
Like this guy was a genius. He didn't have computers to run these simulations, but he could look at an airplane and just kind of know what was going to work and what wasn't going. And so the P-38 Lightning, obviously it looks a little different because it's got 2 fuselages or 3 fuselages, depending on how you count it. And there's a few things that this solved. It made it so that you could put 2 engines into this, and so you could increase your horsepower and your speed, but it also could carry a lot of fuel. But another interesting thing was you could mount the guns right in front of the pilot. So the way that you would do this otherwise is you would put an interrupter gear on your machine gun so that it would shoot in between the propeller blades. Or you mounted your guns out on your wings. Then you would either be shooting parallel bullets, which weren't exactly lined up with your sights, or you would have some convergence, so they would converge in. But then the question was, what's the ideal convergence length? So this didn't have to have interrupter gears or convergence because all of it had like 5 guns or something like that, 5 or 6 guns right in the nose in front of the pilot. So they
Oh.
could just line up and have at it. What I really wanted to talk about on this was another innovation that they came up with for this, and which is cooling the air that's coming into the engine. This pair of engines had superchargers. and usually you need to cool that air, or else your horsepower decreases. If you're pumping hot air into your engine, you're not getting the expansion that you need, so you lose horsepower, or you don't gain as much horsepower as you might otherwise. But if you put a big radiator out there somewhere, you're capturing air and running it across a radiator, but that's drag. Drag is a speed killer in airplanes. So what the P-38 did is, in the leading edge of these wings, they ran a bunch of tubes that they would pump the air from the. I think these had superchargers and turbochargers, if I remember correctly. Damon, correct me. I think
Yes.
it had
Yes, and
both.
if you look up on the back of it, it's fascinating. You can see the turbos kind of poking out. Yeah, right there. Right there where you've
Yeah.
got the
Up
pointer.
here.
Yeah.
Yeah. Yeah, so they had and these had manual waste gates. The pilots could adjust the waste gates on the turbos as they needed to. Anyway, but they had all these tubes running in here, and then there was like a little air inlet here, so air would come in and run along the length of the tubes and exit, somewhere out of the wing. And so the whole front surface, leading edge of this wing, was an intercooler for the superchargers and turbochargers for the engine.
And it's a tiny little opening. That air inlet is just a few square inches. It's tiny. But
it blows me away that was effective enough to do it.
Me too. That's
I wonder
amazing.
if part of it actually was the cooling of that leading edge, the wind blowing across the leading edge of the wing. I wonder if that was a portion of the cooling that they were depending on. So it was drag that they were already committed to, that they needed to help lift the plane, but they're doubling that as their intercooler. I don't know. It's fascinating.
Interesting. Yeah.
Yeah.
What a cool concept.
Yeah. Okay, so this other one, P-51 Mustang. This was a plane that was commissioned by the Royal Air Force from a company in the United States in 1940. They delivered their first prototype airframe 102 days after signing the contract.
Wow.
Let that settle in. A third of a year, like,
Wow.
4 months.
That's nuts.
I get a little panicked thinking about that time frame.
Yeah.
Right? This is one of the really mind-blowing things about that period. It's just the speed of innovation for complex systems. Now there was a lot of iterations that happened, but still, just 102 days to fabricate a brand new airplane. Amazing. So there were several engines that went into this plane, but one of the engines that went into the plane was I believe it was a Merlin engine, which was also running the Spitfire correctly. And in a really interesting thing, and there was other airplanes I think that it was also running, but in the P-51 Mustang, it made more horsepower than in the other airplane. And that is because of its really innovative intercooler. And this is all due to something called the Meredith effect. And the Meredith effect, and it has to do with this little air scoop below the body of the airplane.
Well, this is interesting. I'm not familiar with this concept, so I'm excited.
This is cool. Yeah, so this little scoop on the bottom of the airplane actually produced more thrust than the drag that it introduced. Yeah.
That's
Let that
cool.
sink in. So the Meredith effect. Let's see. Okay. Familiar with the Venturi effect? Hearing about that in science class when you were in high school.
The Venturi effect.
I think that's right. I think the Venturi effect is the one where when you have a volume of a fluid moving through a pipe, and then you narrow down the.
Uh-oh. Did he just stop?
Yeah, he's froze on my end. He is correct. This is the Venturi effect that he's talking about. Carburetors work like that. They have a tube in the top of the engine that you pass air through, and then it's restricted at one point, and at that point you have a straw going down into a little bowl of gasoline. And so carburetors before computers were a thing.
Oh, carburetor.
Oh, there you go. I can hear him now.
Yeah.
Okay.
So blowing the high-speed air would create a vacuum. That's also why airplanes fly, because you compress air and that speeds up, increases the volume across the top of the wing, and that lowers the pressure, and so it creates lift on the wing. But this Meredith effect was described by a British engineer, I believe in the 1930s. Actually got a paper, F.W. Meredith, why it's called the Meredith effect. Oh, 1926. Oh, no. And it was 1935. It was 1935 when he wrote this paper. So he wrote this paper on cooling, and 5 years later, well, it might have been a little bit more than that before they started putting this intercooler on. Let's go back to this. So on the Mustang, that little scoop below the engine was actually smaller at the inlet than it was at the radiators. So this is the inlet over here. It says 2, and then you have the radiators over here. I don't remember what number 3 is. I apologize.
Oil
radiators
radiator.
are up here.
So that's an oil cooler.
Oil radiator.
Yeah.
Oh, yeah. Okay. Yeah. Okay. So this is the oil cooler, and then the engine coolant radiator up here, number 5. Yeah.
Oh, so they just have 2 of these stacked together. There's a smaller little Meredith Venturi and a bigger one.
Yeah. And so the small inlet, and then you open it up. So if you open that up, what happens to the speed of the air?
It'd slow down.
Yes. Slows down. Goes
Pressure
through
would increase.
the radiator. I think you're right. I don't remember. I got to go back and look at it.
It's counterintuitive, but it's opposite of a Venturi.
Wouldn't the pressure decrease?
No, it's counterintuitive, but that's how Venturis work, carburetors work. You've got your tube, and then you've got a constriction in it, and at the constriction, the pressure decreases at the constriction, right? So you do it opposite. You've got a tube, and you have a bigger spot in it. So that's why aneurysms are dangerous. You've got a blood vessel that has like a larger spot on it. At that larger spot, the pressure is higher than everywhere else, and the walls are thinner. So they're dangerous.
So in this, you have that increased pressure, and then it goes through the radiator, and then on the other side of the radiator, the air is heated up as it goes through the radiator.
So you have an
expansion, and you get thrust.
No way.
And you narrow it down,
That's
and
amazing.
it increases velocity.
Oh, that's cool.
So they got something like 17 more horsepower out of the Merlin engine, effectively, or something like that, or 17 miles an hour faster than any other plane that used this engine, because they got thrust out of their intercooler.
Wow.
I love it.
So
Oh, that's so cool. I did not
anyway,
know about this.
there you go.
That's
So
really
many cool
cool.
things to mind.
That
Yep,
is
yep.
amazing.
So you're getting the benefit of cooling it down, but you're not getting any added drag. In fact, you're getting a little extra out of it. That blows my
That
mind.
is
Yeah,
amazing. Yeah.
it's
So
amazing.
cool.
Yeah, and both of these airplanes were just workhorses during World War II. Um, they just played really important roles in uh, the Allies' victories. I don't think I'm overstating that, am I, Damon?
I would no, absolutely not. Uh, the performance advantage that the P-51 had, you're not overstating that. that thing was a hot rod, and it was feared, and rightly so. The thing could deal out some punishment.
Yeah, yeah.
That's cool.
All right. So, Jonathan, have you got something for us?
I do. Now, this is not something. Actually, what I'm going to share has nothing to do with anything that's. Well, when I first start talking about this, it has nothing to do with anything that's currently in the news. Not new stuff. I have a tendency when I'm.
Oh, Jonathan, we've all been doing new stuff, and you're going off old stuff.
Yeah, that's true. Yeah, right. Yeah, all your old stuff, Minecraft. Yeah, old airplanes. Anyway, yeah, that's true. Actually, I was listening. When I'm at work, sometimes I'll listen to old timey radio stations, and so I'll listen to like old Nor uh, uh, radio shows, or I'll listen to.
Wait. Hold on. Are these like recordings of shows from like 1920, or are these like people nowadays like
No,
LARPing as?
these are recordings from shows from the 1940s, sometimes 50s.
No way.
Sometimes you get up to like stuff that was made in the 60s, but
Okay.
so it's interesting. You can find a lot of, at least with what I listen to on Spotify, you can find a lot of just old recordings from those old shows. Stuff like Johnny Dollar, who's this detective who he works for an insurance company, and his whole shtick is that he writes down his expense account, and he's Johnny Dollar, the man with the action-packed expense account, and he talks about everything that his detective work costs him and what he's charging to the company that he's working for. All these kinds of old shows, but one of them that fascinates me has to be listening to old timey science fiction stuff. And specifically, what I want to talk about is when you look at old time science fiction and to see how they project what the future will be. In the year 1986, and they're up on the moon, or you've got a colony on Mars and a colony on Venus, stuff like that. But one that is still, it's fascinating me because we're right in the middle of seeing AI come to be, is how artificial intelligence and robots were depicted in science fiction. And it wasn't just in the 1940s, but you'd see it in the 1980s. I mean, all up until recently, the things that you would expect an artificial intelligence to be really good at would be logic, and it would be like if something didn't logically make sense, you would fry the circuits of the robot, right? The
Does
things,
not compute.
yeah, yeah, exactly.
Turns out a computer doesn't have any problem with that.
Right?
Oh my goodness. And another thing. Holy cow. So it bothers me. Like AI just makes stuff up. Okay. I'm gonna hijack this for a minute, John. Okay. You guys remember us three are old enough to remember the beginning of the internet. And I loved it because it was the Wild West back then. It was great. There was nobody moderating anything, and it was wonderful. I loved it. But the problem is that if you had like a legitimate problem you were trying to find an answer to, there would be 100 answers and 99 of them would be just people making up bullcrap for internet clout. Somebody presenting themselves as an expert. And so our generation had to get real good at sniffing out somebody just making up answers. It's still a necessary skill because AI does that. When I ask ChatGPT stuff that's in my wheelhouse, stuff that I'm expert at, it makes stuff up. It's obviously making it up, and that blows my mind. How is this useful? How? I don't understand. It makes me angry. It makes me confused. I'm old.
Another thing. Get off my lawn.
Yeah. You clankers, get off my lawn.
We don't serve your kind here.
Floor back. I'm done ranting, at least for this point.
I yield my time to the gentleman from Utah.
Well, you're hitting on the thing that has stood out to me as I think about what we used to dream artificial intelligence would be is actually quite different from what it is, what we're getting from it. Because we pictured it's very logical. It's going to be stuck in these things. The only thing that it's going to be able to do is what you assign it to do. And that was because that's the way that computers work. We just assumed that artificial intelligence would be an expansion on that. But then when we get down to it, what we've discovered is that artificial intelligence is actually very good at kind of gut feeling its way through topics. It doesn't care about how accurate it is. What it cares about is it giving it the answer that it was rewarded on. So when you're training artificial intelligence, you go through and you've got a bunch of algorithms set in place that you have one generation that tries a certain thing and it kind of randomly tries it. And whichever of those seeds gets closest to giving you what you want out of a right answer, you give it a reward. Everything else, you kind of kill off. And then you base a new generation off of what was most successful there and with a bunch of slight variations off. And whichever comes closer to giving you the right kind of answer, that's the one you keep, kill everything else off. And you do that for thousands of cycles until this artificial intelligence becomes really good at giving you the kind of stuff that you're looking for. But what that means is that, for example, when you're when you're asking it to make a picture for you, it can make a picture that looks decent until you start looking at the details, like how many fingers does it have. Artificial intelligence has gotten better at making hands without 6 fingers, but it struggled with that. The other thing that it struggles with is continuity. So if you want to know if an image is artificial intelligence, it might look really convincing until you take a close look at it and you're like, hold on a second. Why is that person in the background of this video walking straight off the street and then a semi truck is going right where they were and nobody is reacting? There's like weird stuff like this that you wouldn't expect to happen in real life, but it happens here because the artificial intelligence just kind of makes a gut estimate about what this should look like rather than basing it off of logic like we always thought it would. Clear back.
Are you telling me AI has
80s.
Guts now?
Yes, something like that. This reminds me of an episode of Invader Zim.
The squiggly squooch.
Yeah, that's the one.
I know nothing about it.
Have you ever watched Invader Zim, John?
No, I haven't watched an episode of it. I've seen clips from it.
It might be too weird for your family. I don't know.
I suspect not. I bet I'd enjoy it.
This episode in particular, it's a little bit gruesome for a cartoon. It's hilarious, but it's a little bit gruesome. So yeah, an intelligence with guts. Hey, so kind of along what you're talking about, John. I've noticed that I'm like really like obsessed about details. So like I asked ChatGPT to make a picture, and I told it like a specific model of army truck. I've got a couple of ancient old army trucks, and one of them is a GMC M135. And I said, hey, make this picture, with this GMC M135 doing this. And it made a picture of an army truck doing that, but it was not an M135. It was an AM General M35. And I said, no, that's not it. You made an M35. I need an M135. And then it answered back like with a condescending, like, oh, you're right. You're right. I can see that you're detail oriented, blah, 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 blah. And then I'm like, stop trying to pat my ego and just give me the dang picture. And it could not do it. It couldn't make an M135. Like, to me, that would have been like the easiest thing. You just like, look at a picture of an M135 and then you just barf it back out. But apparently it doesn't work that way. Anyway, there you go. The end.
There was a early on, like early 2000s, a group that used what was called genetic algorithms,
Which is what I was describing, right? Yeah.
Right. Only they were doing this with programmable logic arrays. And programmable gate arrays. And so what these are is it's hardware. You've got discrete gates that you can connect and reconnect. In the early days, it was via a programmer. Then it became connections that you could interconnect through software. What you would make is an extremely fast, like single purpose processor. And so if you had a very specific kind of computation that you needed to do that would take a general purpose computer a long time to compute, you could make with an FPGA, field programmable gate array, board, you could make a very powerful specific purpose processor. And so what this group did is they made it, they used genetic algorithms to let it make random changes. It had a defined set of inputs, and then it had a goal of what the output needed to be and how fast it was done. And they let this run, thousands of times, and it reprogrammed itself over these thousands of times based on what random changes improved or decreased the performance of this FPGA.
Okay, so almost evolutionarily, like whatever works better gets pushed to the top.
Right.
Okay.
Yeah. And so after it got done, they had a board that was incredibly fast. And so then they went in and started looking at how it worked. And it had islands of logic gates just kind of not connected to anything, just hanging out encased in the board.
It had vestigial organs.
Yeah, except for when they removed those islands, it did not work.
No.
It had,
yeah. I read about this.
Did you?
Yeah.
Yeah. So it was using like parasitic capacitance to couple in these gates, and that would somehow increase the speed of this processing.
Oh, that's amazing. No, I've never considered this. That's amazing. Okay. That's amazing. I never considered something like that.
And actually, okay, so to pound on the podium a little bit, I think that's how AI should be used, is to let it go and do a whole bunch of things and find something really efficient, but then you go back and look and see how it did, and then you learn from that, and you actually learn how to program or to manufacture based on that. You don't just let it run amok and then just accept that the answer that it gives you is
Yeah,
okay.
yeah, yeah.
Because
Yeah.
we've seen too many examples where it's not, and actually where car companies are promising that you're going to have self-driving with AI powered. Like, that is terrifying. AI doesn't know when there's a ginormous pothole or it's just something totally random, like a fence laying across the road or something.
Or
It's
a
not going to know what
prankster
to do with
painted a graffiti mural of a tunnel.
Yeah, right.
it. Right. Yeah. Anyway, go ahead, John. We keep interrupting you, but
Oh no, not a problem. I think that's one of my. I think artificial intelligence is really cool, fascinating. There's some neat stuff there, but I do think that there are some dangers when we start relying on it for everything that we do. If as a writer, if I were to go and use artificial intelligence to do most of my writing for me, and then maybe I go and tweak it and say, we're going to do this because this is better. I'm afraid we're going to get to a point where if artificial intelligence is using the writing that people generate to figure out how it should write, and then people are using artificial intelligence to tell them what they should write, it means we're going to get to this stagnation point where artificial intelligence isn't going to learn from what anybody's doing because everybody's just using artificial intelligence to do their work for them. And so
So,
occasionally,
John,
yeah,
uh, I've actually read about this very thing, but it's worse than what you're giving us. It's not just stagnation; it's actually getting worse. Like the AI is it's using crap AI slop as it's part of its training. So each generation is getting worse because it can't differentiate between people produced and AI slop. And when I say AI slop, you know what I'm talking about. The stuff that's that it made
nonsense.
up.
uh huh,
Yeah, that's nonsense. And then it incorporates that in the next generation, the next iteration. And so that next the next output is is much worse than the last.
yeah.
So anyway, yeah, I've read about that.
I think
Yeah.
the way that we avoid that, I think we can use artificial intelligence intelligently, um, but I think it means that
Wait. That means that we have to use our own intelligence?
yeah,
Bah!
exactly, yeah, right. People
Yeah.
have to continue to still use their own creativity, and we can't rely on artificial intelligence for everything. And I suspect in a world where artificial intelligence becomes ubiquitous, then true creativity will stand out, and I suspect people will flock to that. So I don't think we're going to hit that stagnation point. I suspect we'll probably always have people who, just like we have people who care about organic food for everything that they eat. I suspect we'll have people who care about organic intelligence, um, like
Well, I'll tell you this.
natural intelligence.
I spend a lot of time on the YouTube like Elroy, and anytime that it suggests to me AI generated stuff or robo narrated stuff, it gets a thumbs down. I tell it, don't recommend this. I like, I don't want it. I don't want it. Get it out of here. Bah. I guess I want uh
Yeah,
Right.
the
Yeah.
organic brain rot.
And you can tell.
yeah,
I like my brain rot raw and unfiltered.
Yeah.
I heard
Yeah,
something
I don't want to
um,
process.
about AI YouTube channels. Like, there's a reason why there's so many of them is because you can set up a server and start um, generating AI stuff, and you can have dozens of channels that just kind of generate content, and maybe most of those you know don't get much of a viewing, but if you have one of those videos or a few of those videos that start getting some viewership, then you start making money, and it costs almost nothing
mm,
to generate AI content. Just a few inputs, or at least this is what I'm understanding. And so you have people that to make money are just creating this AI drivel,
Yeah.
and just dozens of channels. Like it, for me, like I'll see like something with like a really cool truck mod. I'm like, oh, that looks really cool, and then I look at it and like instead of saying Chevrolet across the back, it's like a garble of symbols that, if you squint,
Yeah.
almost looks like Chevrolet, but I'm like, that's AI. I don't care about it because nobody actually thought about making something like that.
Yeah.
But sometimes there's some stuff that looks kind of cool, Not,
Yeah. Well, I think the skills that I was talking about like being able to discern bullcrap, like at the beginning in the wild west of the internet, are more valuable now than they ever have been, in spite of AI being here. I think now we just have to use it to sniff out AI baloney instead of organic human baloney.
Yeah. I always hate it when I come across some sort of article and I was like, oh, this is fascinating. I pull it up and start reading it, and it's off. You can feel that.
Yeah.
This feels like it's a word salad that's been bled on the page. And at that point, you walk yourself on out of there and find something else to waste hours of your time. Oh, for those of you who are wasting your time here, thank you very much. This is organically grown brain rot.
Isn't it interesting how picky we are about how we waste our time?
Right.
Well, I suppose we should wrap this up. This has been a lot of fun, and I appreciate coming back to this after 4 years, I think it's been.
Has it been that
since
long?
we did our last episode? I think it was
I didn't have
shortly
a
after I
beard.
moved here.
Oh.
And that took a few years to grow.
Yeah.
So,
Well, I've had a lot of fun.
Thank you very much, everyone. We'll see you next time.
all right.